The Passive House at Life Point Cook began with a question: is this possible for the mass market? Passive House is a high-performance, sustainable building standard that aims to produce healthier, more energy-efficient and more comfortable homes. The movement is well established in Europe, and there are about 40 individual architecturally designed examples in Australia. However, the new Passive House at Life Point Cook investigates the potential for this type of home to be delivered on a broader scale. Join us on our tour today and find out more as we open our doors to the first Passive House designed and built for the mass residential market in Australia.
Welcome to the garage of the Passive House. So here we house a few bits of tech that are critical to the performance of the Passive House. So we have the heat recovery ventilation system, also known as HRV system, the solar battery and inverter, and the Watt Watcher smart energy meters.
Here we've got a small piece of kit which will measure the energy efficiency of the home. It will measure exactly how much energy is being used throughout the year and the day, and it will also measure where the energy is being used, whether it's the cooktop, the hot water heating system, or potentially even the heating and cooling system of the house. So down the road we have a house which is exactly the same layout and design, but built to standard construction code. We will then be able to take its data and compare it against the Passive House data to see exactly what performance uplift we will actually get from this house.
So here we have the heat recovery ventilation system, also known as a HRV system. Now this is really critical for all Passive House houses. It allows fresh air to come into the house without a significant loss of energy. So inside this HRV system, there are a couple of fans and a heat exchanger, and all the air that's being exhausted from the house passes through this and pre-cools or preheats the air that's coming into the house. So through this system, we save about 90% of the energy that would normally be lost from exhaust.
There are 18 350 watt Hyundai solar panels on the roof here, which is 6.3 kilowatts of solar. This will produce approximately 8,200 kilowatt hours of clean energy every year, which is the equivalent of planting 30 new trees annually. If this energy is used in the home either directly from the solar panels or via the battery, the savings would be approximately $1,800 per year.
So here we have the battery for the home. This is supplied by our partners at GI Energy, and it holds 11 kilowatt hours of energy. So this will power the home from sundown to sunrise. If the family choose to use this battery every day, they will reduce their carbon footprint by 3 tonnes every single year. So because this is a passive house that uses a very minimal amount of energy, there's likely going to be a surplus of energy generated and stored in this battery. So the family will be able to use it for things like charging an electric vehicle for free. Normally, a passive house has smaller windows due to the high cost. However, Frasers made the decision to keep the windows large and maintain the intent of the home. As you can see, these windows may not look any different, but they are extremely well sealed, thermally broken, and well insulated. They also have a tilt and turn function. The beauty about living in a passive house is that everything works together as a system. So if you do actually want to have your windows open, the thermal performance of the rest of the house will keep you nice and cozy. Likewise, if you want to have your windows closed, you aren't sacrificing fresh, comfortable and healthy living environments inside.
Here in the Passive House, we've got windows both up and downstairs, including all the bedrooms and living areas to ensure a lot of natural light, all with double glazed and timber frames. The benefits of using the imported windows from Europe ensure that we're using tried and tested windows that have been used in previously certified passive homes. Really important that with the Passive House, we're making sure we're hitting our air tightness, our heat mapping, and other key criteria in achieving that certification. These Logic House windows have ticked those boxes many times before and gave us a lot of confidence going into construction.
Because Passive House components are so high performing, we have to look at different paths of heat than we normally would in a regular house. So not only is the glass extremely high performing, it lets in light while preventing heat from transferring through, but the frames are also really high performing. They're about 10 times less conductive of heat than a frame would be in a normal house. So not only do we look at these two elements, but we look at how they're installed. So we have to look at how the frames are installed to make sure that there's no heat passing between the frames and the walls, and we have to look at how the glass is installed into the frame to make sure that the edge of the glass isn't also conducting heat.
2 key criteria in achieving Passive House is the use of our walls to ensure we get our air tightness as well as meet all our heat modelling requirements. by use of insulation and wall wrap.
The construction of this house comprised of 3 walls. Firstly, you had the perimeter wall being the brick wall. Then when we go internally, there was another 90mm wall, which we treated with the internal membrane and the external membrane, which was the most important component of this house. And now, after that, to allow us to service the house with electrical and plumbing works, we build the 3rd wall inside of 70mm timber, and that allows us to rough in the house without undermining the membrane on the internal wall.
A really important part of building Passive House is the wrapping of the external walls to ensure we can achieve the 0.6 air changes per hour. Comparing that with normal homes where they have up to 10 to 15 air changes per hour, you can imagine why these homes are so energy efficient. One of the most important tests when building Passive House is the blower door test. This involves both a positive and negative test, pressurizing the home, whether it be either vacuuming through a door or a window. Basically, a formula is used to work out where the air changes per hour lie with that target of 0.6.
With the certification of this pilot project, Frasers Property becomes the first volume developer to explore passive house design and construction techniques in standard Australian home design. With the combined efforts of our key project partners, we look forward to influencing our systems and supply chains to provide a more energy efficient, sustainable standard for all our customers as we work towards a more sustainable future. By capturing real data about the comparative energy use of 2 homes that are the same in terms of layout, but one being built to the Passive House standard, we can provide our customers and the industry with hard data about the cost benefit of building with sustainable energy use in mind.